Today we will be discussing about large sample test. When we are testing the hypothesis, if the sample size is greater than or equal to 30, we need to consider the Z test to test the given hypothesis. This test is used to find the significant difference between the population and sample mean, the population and sample mean. The following steps are needed to test the given hypothesis using Z test. Firstly, we need to set the null hypothesis and the alternative hypothesis according to the given problem. We have a simple relation to find the Z statistic, that is Z is equal to x bar minus mu by sigma x bar, where x bar is sample mean, x bar is sample mean, mu is population mean, mu is population mean, and sigma x bar is error. To remove this error, we are considering two different methods. When population standard deviation is known, consider sigma x bar is equal to population standard deviation by square root of the sample size. In case if the population standard deviation is unknown, when population standard deviation is unknown, consider sigma x bar is equal to sample standard deviation by square root of the given sample size. After this, set level of significance. Generally we are considering the 5% and 1% level of significance for the given two-tailed test and one-tailed test. If we consider 5% level of significance or 0.05 level of significance, the observed or tabulated value of Z for the given two-tailed test is 1.96 and for one-tailed test is 1.64. Similarly, if we consider 1% level of significance or 0.01 level of significance, the value of Z is 2.58 for two-tailed test and 2.33 for one-tailed test. Finally, we are comparing the calculated value of Z with the tabulated value of Z. Suppose if calculated value of Z is less than tabulated value of Z, we are accepting the given hypothesis. We are accepting the given hypothesis. Otherwise, the hypothesis is rejected. Otherwise, the hypothesis is rejected for different level of significance. That is, 5% level of significance or 1% level of significance based on the value of Z. Now I will consider a problem for the given Z test. Whenever we are solving the problem, we have to be careful about what sample size he has given. Based on the given sample size, you consider whether we need to apply Z test or T test. If the sample size is less than 30, then we have to consider T test. If the sample size is greater than 30, then we need to consider the Z test to test the given hypothesis. If we consider this problem, we can see what actually he has given. In the given problem, clearly it says that the mean lifetime of a sample of 1000 fluorescent tube lights manufactured by a company is found to be 1570 hours with a standard deviation of 120 hours. Clearly, the mean lifetime of a sample of 100 fluorescent tube lights, that means clearly the sample size is n is equal to 1000 and the sample mean is 1570 hours, and also he has given a standard deviation of 120 hours. That means S value is also given, that is 120 hours. Now the question is, we need to test the given hypothesis that the mean lifetime of the lights produced by the company is 1600 hours. That means let us consider the hypothesis, that is the mean lifetime of all the lights produced by the company is 1600 hours. That means the population mean is 1600 hours. Now for the distribution X bar under the given hypothesis H, the mean and standard deviation is given by mu X bar is equal to mu, that is equal to 1600, and here the population standard deviation is not given and sample standard deviation is given, so that you consider sigma X bar is equal to sample standard deviation by square root of the sample size, that is 120 by square root of 100. So that means the value is 12. Now let us consider the Z score for the given hypothesis. If we consider the test statistic, Z is equal to X bar minus mu by sigma X bar. So that this becomes X bar minus the population mean is 1600 hours and the sigma X bar is clearly it is 12. If we consider the sample mean, X bar is 1570 hours, 1570 minus 1600 by 12. So further, if we simplify the given equation, we will be getting the value of Z is minus 2.5. The value of Z is minus 2.5. Suppose if we consider 0.05 level of significance, clearly the given Z score minus 2.5 that lies outside the given interval. That means Z is equal to minus 2.5, that does not belongs to minus 1.96 comma 1.96, so that we are rejecting the given hypothesis for the 5% level of significance or 0.05 level of significance. the hypothesis is rejected. Similarly, if we consider 0.01 level of significance, the value of z is equal to minus 2.5 that lies inside the given interval. Inside the given interval means the value of z is minus 2.5 that lies between minus 2.58 and 2.58, so that we are accepting the given hypothesis for 1% level of significance. For 1% level of significance. So this is how we can solve the given problems using Z test. Now I will take another question using Z test. Clearly the question says a random sample of 100 recorded deaths in a year showed an average lifespan of a random sample of 100 recorded deaths in a year showed an average lifespan of 71.8 hours, assuming a population standard deviation of 8.9 years. The question is, does the data indicate that the average lifespan is greater than 70 years? That means we need to consider the hypothesis is the average lifespan is greater than 70 years. Now using 0.01 level of significance, we need to check whether the given hypothesis is accepted or rejected. Firstly, I will consider the data what he has given. In the given problem, clearly the sample size is given, that is 100, and the sample mean is given, that is x bar is equal to 71.8 years. 71.8 years, that is the sample mean, and also the population standard deviation is given. The population standard deviation is 8.9. The population standard deviation is 8.9. Now for the distribution x bar, mu x bar is equal to the population mean, and sigma x bar is equal to, clearly the population standard deviation is given, so that population standard deviation by the given sample size. Further, if we simplify this equation, we will be getting 8.9 by square root of 100. Finally, we will get the sigma x bar value is 0.89. So now I will considering the hypothesis H. The hypothesis H is the population mean is greater than 70 years. The population mean is greater than 70 years. That means we need to consider the hypothesis is mu is greater than 70 years. Mu is greater than, population mean is greater than 70 years. Now let us calculate the value of Z, that is Z is equal to x bar minus mu by sigma x bar. If we substitute all these values, we can consider x bar is 71.8 minus the population mean by 0.89. Under the given hypothesis, clearly we can write 71.8 minus mu by 0.89, which is less than 71.8 minus 70 by 0.89. This is approximately equal to 2.022. So clearly the value of z is less than 2.022. If we consider the 0.01 level of significance or 1% level of significance, the value of z score is lies the given interval, that is z is less than 2.022 belongs to the given z score, that is minus zc comma plus zc. Therefore we are accepting the given hypothesis. So that means the data indicates that the average lifespan is greater than 70 years. The average lifespan is greater than 70 years. Thank you.